Hi there. I was hoping to work a problem for you that had to do with confidence intervals for means. In other words, we're going to estimate a mean. Here's the example. A university wanted to get an idea of how much students were spending on textbooks each semester. They want to know mu, the population mean. In order to figure that out, they had a questionnaire of spending habits that was given to a random sample of 40 of their students. Each student was asked to record the amount of money they spent on textbooks in the prior semester. The sample of 40 students resulted in a sample mean of $422 with a standard deviation of $70. Create a 95% confidence interval for the mean amount all students spent on textbooks each semester. So this is a pretty classic problem for confidence intervals. The university wants to know the population mean, and they can't ask every student this question, so they settled on a sample of students, and they're going to use the results from that sample to create a confidence interval. In other words, estimate the true population mean with that interval. So before we get started, I wanted to point out some important features in this problem. I've kind of tried to use some colors here to help you out. Information that we would either need to plug into formulas if you are plugging these into formulas. In our case, we're going to put them into StatCrunch. The first is there's a sample of 40 students, so that gives us some information, tells us what N is. And I said in that sample, there was a sample mean of 422 in red, that's X bar, and a sample standard deviation of $70. That'll be our S. Finally, the level of confidence they want to use is 95% confidence, and that will also give us some information. If you're using formulas, that would give you Z star, as I call it, or your critical Z. If we're using software, we'll just have to let the software know how confident we want to be. So here I'm going to go to StatCrunch, and with these ideas in mind, these values I just put in the same colors as the slide before. The 422, the 70, 40 in our sample, and the confidence level. So let's go to StatCrunch. So in StatCrunch, you're going to navigate to Stat, T-Stats. Now the reason we're going to T-Stats is because we'd like to use the T-distribution. When estimating means in my course, we use the T-distribution because oftentimes if we don't know mu, we don't know sigma either, and that will put us in a situation where we should use the T-distribution. Oops, that went away. T-Stats, one sample with summary. So what we were told from the university that did this was just this sort of summarization of what they found. They didn't have us look at the whole data set. If we had the whole data set, we would have chosen with data. So when we do this, we'll see that we'll get queried for some of the things we already know. What was our sample mean? Well, that's the $422. The sample standard deviation was 70. The sample size, 40 individuals, 40 students. And right now it's set up for a hypothesis test. That's not our aim. Our aim is to do a confidence interval, so we literally need to click to perform a different task, which is a confidence interval. And as you can see there, the confidence level, the default setting is 95. Now this is, you can change it to any 99 or 93 if you wanted, but 95, so it's completely a box you can change. And then we'll hit compute. And what you see here is our output. So it reminds us the sample mean. It also tells us the lower limit, the lower confidence limit, and the upper confidence limit. So these are the limits of our confidence interval. So let me show you what that's going to look like. So here we have sort of a generic confidence limit. We have to keep our mind focused on what the heck these things are, because sometimes software makes it too easy for us. We're creating an interval with X bar in the middle, our sample mean, and we're going to go to the right, a margin of error, and to the left, that same distance called margin of error. That creates the lower confidence limit and our upper confidence limit. So for us in our problem, I've inserted our information. There's 422 here in the middle. Our upper confidence limit, said StatCrunch, was $444.39, rounded to 2 decimals here since it was money. Our lower confidence limit, that is $399.61. So they were given that. Now the margin of error was not directly given to us from the output, but I can surmise just from looking at this, if my middle value is 422 and the upper limit went as far as $444.39, that they basically added $22.39. Of course, that makes sense if you do the arithmetic on the left side. They subtracted $22.39. So our margin of error for this problem in the same unit as our data is $22.39. Well, the college, again, their idea was to try to estimate mu. So here's a sentence that we traditionally follow confidence intervals with. It says we are 95% confident that the mean amount spent on textbooks in a semester for all students at this university is between $399.61 and $444.49. So again, we can't say we know where it is in this interval here, but we're 95% confident that our population mean mu is somewhere inside of this interval. Thanks a lot. Let me know if you have any questions.